Hello, everyone. I'm very pleased to be here, and I'd like to welcome you to my presentation, Harmonizing Complexity, Collaboration amidst parallel project phase and a wide range of stakeholders. So as the title suggests, it will cover a project example within its very complex environment. At first, my name is Robert Felker. I studied civil engineering in Oldenburg, Germany. I took my first professional steps in structural engineering about 11 years ago. During that time, I had my first contact with BIM as we had already transitioned all internal planning processes to a model-based work. After that, I joined Zechbau Holding, a bigger German general contractor, where I was responsible for the administration of Autodesk Revit and implementing BIM processes together with the whole team. I have now been with Frame Consult for about 8 years, where I initially was a consultant for organization strategies and acquisitions. Over the time, I developed a specialization in BIM management because I successfully completed a large number of projects as a BIM manager in Germany and also for a big international project. For the past 3 years, I have been the CEO of the company, leading a team of nearly 10 BIM managers who oversee more than 30 projects. Frame, who are we? Frame is a company that helps building owners, investors, project developers, and other clients to go digital and to become more efficient in different aspects. We are specialized in providing consulting and management services related to digitalization and building information modeling. The base of our company is in Berlin, but we are also located in different countries of Germany. Through our different locations and our remote staff, we cover the whole territory of Germany. We have an interdisciplinary team of more than 30 colleagues of various nationalities and professional backgrounds. We are members of various international and national committees such as Building Smart, VDI, the German Engineering Association. And we also focus on teaching, giving different seminars and lectures at different universities. Our working influence is very extensive, allowing us to help our clients in the whole range of possibilities to optimize the processes. All over, we have 5 work teams. The first is BIM and information management, which manage the different projects that our clients have, controlling the development of the BIM models of the project and the management of the data and information of this. We also have a team of developers who adapt solutions to the client in terms of software, especially for building projects and life cycle. Over the last few years, we have built up also a team of experts in large-scale infrastructure projects, especially for the energy market and such as transport networks. Another big part of Frame is our strategy team, consultants who analyze each specific case and identify the problems and propose solutions for better efficiency in the companies. Finally, our transformation and change management team that helps in complex cases in which clients need extra support in the management of employees, improvement of dynamics for a perfect digital transformation. The project lead. Now let's move onto the main part of the presentation. I would like to introduce you to the very complex lead project, which we have been managing for the past 4 years. In this project, we perform tasks of the manager and also as a data manager in all phases of the project. The project started in 2020 and we started with it in schedule to be completed with the active BIM-based facility management in summer of 2025. The building in question is a new construction, the laboratory and office building within a large area of the owning company in South Germany. The building costs are about 250 million euro with a space of 40,000 square meters. The building is intended to be one of the most modern and sustainable research facilities in Europe. More than 800 employees will conduct the research there. The difficulty of the project was based on the structure of the project, divided into two inside projects, carried out by different work teams, each with different working methods, which we had to manage in terms of communication and also with the collaboration with others. Let's take a look how the project is structured and what the technical environment of the project is. So what are the challenges? We have a high number of stakeholders with different interests in the project. So we have on the client side, the user stream and the site engineering, which provided the project to the user. In the laboratory part of the building, we have individual contracts with the planners and a high number of disciplines. The office side of the project is being constructed using a timber hybrid construction method and has a specialized general contractor was sought for this proposal. Each of these stakeholders had an individual working system with parallel project phases that overlapped and conflicted with each other, and many software that we have to make work together. On the next slide, you see the organizational flowchart of the project, where you can clearly see the two working groups for the two buildings, lab and office. Above, we can see the BIM responsibilities on the client side, where we are assigned as the BIM managers and our direct contact to the client, the BIM process owner of the organization in this project. It's particularly important for us in our role to ensure effective communication among all the parties involved. On the next slide, you can see the complex technical environment of the project. The complexity results from the history of the project. The client basically used Avero as his document management platform. However, no BIM processes are mapped here. The client has therefore introduced Revisto for coordination and collaboration. We at Frame are responsible to administrate Revisto that all processes run smoothly. The planners involved at the beginning of the project worked a lot with BIM 360 and wanted to work with BIM 360 for model exchange internally. This gave us this complex structure. In addition, there is also a data-based room book application, which is called Prevera, with which participants manage the special information over all stakeholders regarding spaces. At the end of the project phase, we also use Solibri for model checking on the BIM management side because it makes it possible to carry out functional checks in addition to collisions. One example for that is maybe a free space in front of windows, or check whether whether the minimum heights in the floors have been maintained. In this picture, we want to show you the various technical environments for each project phase. As I said, it develops on the history of the project. So in the early project phase, we use Solibri to test IFC files and the project base of all models. And from the basic design onwards, we switched to implementation with BIM 360 and Navisworks for the coordination process. From detailed design onwards, we upgraded the project to Revisto Plus, which allows us to implement the clash detection entirely with Revisto. From this point, we are able to streamline the checking process and conduct the coordination meetings entirely in Revisto. Everyone on Revisto Plus has access to the latest collision reports and the results. Okay, so what use cases have we set up for communication and collaboration in Revisto? So we have the model coordination and quality assurance. We have the structured issue management in it. We have the change transmission and management, comparison of models from detailed design and installation planning models, because we have overlapping phases, model evaluation based on object information, snagging or defect detection and documentation, so checking the deviations between model and construction site. We have the tracking process for opening voids, comparison for fire protection concepts in 2D with implementation of the models, what we will see later, and the user vote, facility management, and the safe, healthy, and environment, what we have in the project. The Revisto implementation. Okay, let's come to it. To manage the complexity of the project structure and the various applications involved, we have implemented Revisto. What we have done there is, at first, we have here our complex collision matrix implemented in Revisto Plus. Once the matrix is cleverly implemented in Revisto, further checks can be carried out extremely efficiently, including the automatic assignment of issues to the relevant parties. After each update of the review, you can quickly see how much has been processed and how many new issues have been added. Everyone has access to these collision detection and the results in Revisto. And another important thing is that the editing of the rules can be restricted through permissions. So the manager can maintain this part of Revisto. Here are some examples how the results are presented in it with the viewer. After the clash detection has been performed, the results can automatically be generated as issues. In the issue tracker, we can see here, issues can also be manually created, whether they arise from fly through the model or during coordination meetings. You can see the issue tracker, which allows us to manage and track all issues of the project using Revisto and its model viewer. After clicking on an issue, we can see an example of communication through BCS in the project and the connection directly with the model loaded in the platform. An important process in this project was to track the client-side changes that are introduced very late in the project. We have also implemented this in Revisto, as shown in the example here. Change orders or change requests are created also as an issue, and their status is recorded in the issue tracker. Only when changes have been incorporated into the model, they were marked as completed. Another aspect of the process is communicating changes resulting from the overlap of phases from detail design and the construction and the commissioning with the contractors. We will do this digitally and through the platform. It's much easier to understand what has changed, and the issues can be effectively tracked. Okay, another topic what was implemented on the platform is to compare objects on site with the models. Deviation must be documented here, and the models have to be adjusted to get an as-built model at the end of the project. For the shell construction, this was done using point clouds, which were compared with the models. Deviations were created as issues and assigned to the relevant responsible modeler. In addition to capturing the current state with point clouds, site inspections were also conducted. Deviations noticed during these inspections were also recorded and created as an issue, like you can see here with a photo on it. What can also be effectively done through the platform and in our project is color coding information within the building components. This example you can see here was used to track the status of openings or voids in the project. The red one you can see here were rejected in the process. Yellow ones are pending in review, and the green ones are approved. This gives us an easy overview about the status of the process during the project. Sorry. Another functional analysis, for example, was to generate filters or visuals to analyze the attributes of the different elements in terms of fire protection. In this project, we have a fire protection planner who does not create models, but only provides overview 2D plans. Therefore, we set up a process so that the architect transfers the information into their model. You could imagine this process is prone to errors. So for quality checks, we color-coded the information in the architectural model and cross-checked it, like you can see here, with the 2D overviews provided by the fire protection planner. This also provided us a great confidence during this process in the project. In a laboratory project with even individual planners and separate contracts, the interface between laboratory planning and the MEP is very important. To ensure that the requirements for laboratory equipment and the placement of connections work well, the interface between these two had to be coordinated based on the models in this case. We discussed there are 3 different levels of implementation within the team. Level 1 is the purely geometric representation of the interface location using these small blue boxes you can see, along with lists detailing which box contains which requirements. Level 2, the geometrically placed boxes, but also with added parametric information within the boxes that include specific requirements. And the level 3, a bidirectional interface between the model and the equipment catalog of the laboratory setup. Yeah, at the end, the project decided to implement level 2. So it means all connection points on the laboratory equipment, including requirements for service and media, was done in the model. In this slide, you can see how much information is needed for this process for each equipment at each box. You can see here the geometrical boxes, but also the information and the parameters have been put there. Yeah, finally, we implemented VR visualization for decision making, or just to get access to the project for everyone. In the project office is a VR station located that can be booked at any time to view the current status of the model. This is especially used by the end users of the building and those who are responsible for safety, health, and environmental aspects, and also facility management. Okay, thank you once again for the opportunity to present this project implementation to you. I hope you found some interesting aspects in it. Yeah, I really enjoyed the experience. For further questions, don't hesitate to contact us. Thank you very much.